Hello, good morning students. This is your Jagadish Kumar Bandaru. Today, I am going to explain lateral displacement. This is one of the most important concept in ray optics. So when light ray passes from glass slab, so I am going to consider this is the air medium. This is also air medium. That means in the air medium, we are going to place the glass slab. This is the glass slab. So air medium, in the air medium I am going to place the glass slab. Light ray passes through glass slab. So this is the incident ray. And this is the emergent ray. Actually, this is the original path. If there is no glass slab, light follows the rectilinear propagation of light. We know that. That means light ray travels always in the straight line. So, if in the same medium, always light travels in a straight line. So, if there is no medium change, then what happens? That incident ray travels in this path. This is the original path of the light ray. And I am going to denote it with the dotted lines. The original path of the light ray. This is the incident light ray. The inside is refracted light ray. This is the refracted light ray. Now this is the emergent light ray. So the dotted lines represents original path of the light ray. Original path of the light ray. This is the situation. Here the angle between incident ray and normal. This is the normal. This black line is the normal. And here also the black line is the normal. So the angle between incident ray and normal is called incident angle. The angle between refracted ray and normal is called refracted angle. So vertically opposite angles are equal, correct? So here this is the incident angle, means the total angle is incident angle only, I only. Then what is the extra angle here? This angle. What is this angle only? This is I. From the I need to subtract R. At the time I am going to get this angle. What is this angle? I minus R. I minus R. This angle. That is angle between refracted ray and original path. That is I minus R. That is the angle. Now here what happened? What is the lateral displacement? We will see first of all. When light ray passes through glass slab, the incident ray and emergent ray both are parallel to each other. Incident ray and emergent ray both are parallel to each other. But emergent ray displaces laterally. Emergent ray, let us see, this is the original path, no? This emergent ray displaces laterally. But emergent ray displaces laterally. That means this is the original path. So this is the emergent ray. That emergent ray displaces laterally. This lateral displacement. This laterally displaced, no. This is known as lateral displacement. This is known as lateral displacement. This is known as lateral displacement. That means from the original path, how much it is displaced, that is the lateral displacement. This is the perpendicular line. The perpendicularly how much it is displaced, that is called lateral displacement. So here what is the lateral displacement? This is the lateral displacement. That is I am going to consider some x. That is I am going to consider some x. What is x? Lateral displacement. X is the lateral displacement. Now we can understand what is the lateral displacement. Now how to calculate that lateral displacement we will see now. Here I am going to consider this triangle. This triangle. I am going to consider the triangle A. This is B. This is C. Considering triangle A, I am going to consider A or B. A, B, C. A right angle triangle, observe. Here 90 degrees. Why? Because this is the perpendicular, laterally displaced, I said no. So this is the perpendicular line between the emergent ray and original path. What is the lateral displacement? A lateral displacement is nothing but that is the perpendicular distance between the emergent ray and original path. That is x. So this is the 90 degrees. So in triangle ABC, in triangle ABC, AC is the hypotenuse. Why? Because that is the side opposite to 90 degrees. In triangle ABC, AC is the hypotenuse. Why? Because that is the side opposite to 90 degrees. Then, what is the angle at this point? I minus R. So I am going to write sine I minus R in the triangle ABC. What is the sine I minus R? This is the angle here. I minus R, this angle. In the triangle ABC, what is the angle at A? At A means at BAC. At BAC. What is the angle? I minus R. So that is opposite to this angle. Sin theta means what? Opposite side by hypotenuse. I am going to write here. Angle BAC is equal to what? I minus R. Sin theta. What is sin theta? Opposite side by hypotenuse. Sin I minus R. What is the opposite side here? X. What is the hypotenuse? AC. What is the hypotenuse? AC. That AC I am going to consider some L. Some L. I am going to represent it with L. What is AC? L. X by L. Here what is L? Distance travelled by the light inside the glass slab. Light travel from here to here, no? What is L? Distance travelled by the light or light ray inside the glass. So that is L. L means distance travelled by light ray inside the glass. Inside the glass slab. Right. This is one of the equation. This is one of the equation. Now consider another equation. Now consider another equation, that is one more triangle. If I am going to consider this triangle, A, D, C. I am going to consider A, D, C. ADC triangle. ADC triangle. In ADC triangle, what is AD? Thickness of the slab. Thickness of the slab. What is T? Thickness of the slab. That is only AD. What is AC? What is AC? The distance travelled by the light ray inside the glass slab. So in triangle ADC, in triangle ADC, what is cos R? Calculate cos R. Cos R means adjacent side by hypotenuse. What is the adjacent side in triangle ADC? Adjacent side is AD. AD means thickness. Hypotenuse means why? Because this is the 90 degrees. AC is the side opposite to 90 degrees. That's why AC is the hypotenuse. Then what is the hypotenuse value here? L. L. This is the L. From here, what is L? From this equation, what is L? T by cos R. From this equation, write down this equation, write for L. L is equal to T by cos R. This is considered equation 2. Now substitute equation 2 in equation 1. Equation 2 in equation 1. Then what I am going to get? Sin I minus R is equal to x upon, what is L? What is L from equation 2? T by cos R. T upon cos R. T upon cos R. That cos R goes to numerator. T upon cos R. So that cos R goes to numerator. So cos R. X cos R by T. From here I need to calculate x. No? What is x from here? X is equal to cos R by T transposed to sin I minus R side. Then what is x from here? Cos R by T transposed to sin I minus R side. Then reciprocal T by cos R into sin I minus R. I required x. X is equal to what? Cos R by T transposed to sin I minus R side. Then T by cos R into sin I minus R. So this is what equation for lateral displacement, where x is the lateral displacement. Then how to calculate lateral displacement? By using this formula. T by cos R into sin of I minus R. Where T is what? Thickness of the glass slab. Thickness of the glass slab. What is R here? R is the refracted angle inside the glass slab. Refracted angle inside the glass slab. Where what is I? What is R? I minus R. I minus R. That is the deviation from the original path. What is I minus R? Deviation from the original path. That is I minus R. Where I is the incident angle, R is the refracted angle. But I minus R is the how much angle it will be deviated from the original path towards the normal. I minus R is the how much angle it will be deviated from the original path towards the normal. That is the I minus R. That is the angle of deviation we call it as. So by using this formula, one can calculate lateral displacement. My dear students, remember here, what is L here? What is the L? Whatever we are going to use it here. The L is nothing but distance traveled by the light ray inside the glass slab. Suppose he is asking what is the distance traveled by the light ray in glass slab. How to calculate? By using this formula. By using this formula, how to calculate? By using this formula, L is equal to what? L is equal to what? Transfer the cos R towards the T side. Then T upon cos R. What is L from here? From this equation, write this equation for L. L is equal to T upon cos R. This is the formula we are going to using to calculate what is the distance traveled by the light or light ray inside the glass slab. Inside the glass slab. L is equal to T by cos R. Here L is the distance traveled by the light ray inside the glass slab. T is the thickness of the glass slab. Thickness of the glass slab. And R is the refracted angle inside the glass slab. Okay, my dear student. If you like this video, please share, like and subscribe. We will discuss next concept in next video. Thank you, my dear students.